Hi class! In today's video notes, we're going to be talking about what's called a box plot. Now you may also hear of it as a box and whisker plot. And basically what we're doing is we're going to create them, compare them, and analyze them. So here's a cute little visual of what a box and whisker plot looks like. So the body right here is the body of the cat, and then it has two little whiskers that shoot off of it. So to get started, what is a box plot in general? And a box plot is a way to display data on a number line by organizing it into four sectors or four different sections. So they use the rectangle to represent the middle half of my data, and then the whiskers that shoot out on either end represent the remainder of the data. So we have the lower quarter of the data, the middle half of the data here, and then the upper quarter of the data. So all of the data is basically split into four equal parts, and then you have what's called the 5-number summary, which consists of the minimum and the maximum, so the lowest and highest number that you have, and then the lower quartile, which is right here on the edge of the box, the upper quartile, which is the top end of the box, and then the exact middle point of your data is called the median. So there is 5-point summary, as I just stated, and this is how we break our box and whisker plot up into the different 5 points that create the boxes and the whiskers. So there's a couple different ways that you might hear of the lowest data point that we have right here, which is called the minimum, or MIN, or the lower extreme, because it is the extreme lowest point of our entire data set. It's the smallest value that we have. Now the lower quartile is, so all of our data is split into four sections. So here's 1/4, here's 1/4, here's 1/4, and here's 1/4. And the way we get those fourths is by first splitting our data in half by using that median, which is the middle, and then we split it in half again. And when you split something in half and then in half again, you're splitting it up into fourths. So the lower quartile, and notice how quart is like quarter, and there's 4 quarters to $1. You're basically splitting your data in half and getting that median, splitting it in half again and getting that lower quartile. So the lower quartile is the median of the lower half of my data that I have right here. So I took my data, I split it in half, I split it in half again, and that gave me my lower quartile. And it's the same idea for the upper quartile. It's just taking the top half of my data and splitting it in half again, which is evenly splitting my data into 4 sections. And then we have our upper extreme, which we can also call the maximum that we have right here, and that's just the highest point of my data. So once again, we go from the minimum, we split our data in half between the minimum and the maximum and get that median. And then we split it in half again and get our lower quartile and our upper quartile. This will make a little more sense once we do the practice together on how we actually arrange a box and whisker plot. So the quartiles, as I stated before, are basically splitting it into 4 sections, and each quartile, no matter what they look like, will always have 25% of the data, or 1/4 of my data. So we could have a really nice box and whisker plot like this, where we have the minimum, the lower quartile, the median, the upper quartile, and the maximum all evenly spaced. Notice how they all look about the same. And sometimes that will happen, and it'll make sense that they're all split into quarters, like we have here 1/4, 2/4, 3/4, and 4/4. But sometimes, like these ones over here, we're going to have a really big section like this next to a really small section. The sections will always still be worth 25% of the data. No matter how big or small they look, it's always going to be 25% for each of the sections. So even though this quarter is a lot bigger than the other quarters, it's still only worth 25 cents. So even if the data points look different like this, they still are cutting all of the data points into those 4 even sections. It just means that the data points within here are spaced out more than the ones that are in here, which are closer together. So what would you call this point on the data set that we have right here that I'm circling? What would you call that? Well, that data point we know is our median, or our minimum, excuse me. So we have our minimum here. What would you call the data point that I have with a star right there? The star would be our upper extreme or our maximum. And then what about this one with the triangle in the middle of our box and whisker plot? The middle point of our data point would be our median. And then what would we call this one on the heart? That would be our lower quartile. And then this one with kind of a cloud would be known as our upper quartile. It is super important that you know these different vocab words because when we go into examples, you have to know what they're talking about. So let's say I had a question and it asked, what % of the data is held within the box that we have right here? How much data is in that box? Well, knowing that each of these sections that we have on our box and whisker plot account for 25%, I know that I'm taking this big 25% and this small 25% and adding them together, and the entire box that we have is 50%. So the quartiles are the 4 sections that make up the box plot, and each of them have 25% of the data, as we just talked about. So we'll have quartile 1, quartile 2, quartile 3, and quartile 4, because I split it up into 4 equal sections. And once again, we have 25% of the data in each of them. So you could be asked how much is held from the upper quartile to the lower extreme, and that would include this section, and this section. So all that data would then be 75% of my data between these 2 points. So then we're going to talk about range and inner quartile range. So the range is the difference from all the way to the top to all the way to the bottom. So it's taking our maximum and subtracting our minimum. You should be pretty familiar with the idea of range by now. So in this case, our maximum is 30 minus our minimum, which is at 14 on my number line. So my range would be the value of 16. There's 16 spaces between our minimum and our maximum. The inner quartile range is the range between our box, basically. So from our upper quartile that we have right here to our lower quartile is going to be our inner quartile range. And the way you do that is you take your upper quartile, which is at 26, and you subtract out your lower quartile, which is at 18, and you get that the range that we have right here is that space that's making up our entire box. And we know that that's 8. And then when there are an odd number of data values in the set, the median itself is not going to be included when we're calculating that lower and upper quartile. And I'll explain that a little bit more when we do an actual problem together. So we have our median here, right in the middle of our data. So there's a few steps that come to creating a box plot. And this might look a little overwhelming, but it's really not that bad. The first step, which is super important, is to organize your data from least to greatest. So you could be given all sorts of numbers like 8, 5, 7, 2, and 9. You first need to organize them from least to greatest so you can figure out which one's the lowest, which one's the highest, and then which one's in the middle. You then determine your median. And if there's an even number of data, you take the mean of the middle 2 numbers to find that median. And if there's an odd number, then the median is just that value, and it's not going to be included when we're finding the quartiles. You then calculate the 5 data points. So the lower extreme and the upper extreme are pretty easy. They're just the lowest number and the highest number. The median we calculate by basically counting. So let's organize these data points. So 2, 5, 7, 8, 9. To find our median, we tick off the low and the high and keep going until we get to that middle point that we have right here. So the median of my little data set is 7. And then you're doing that again. You're finding that median going from the lower extreme to the median to find those lower quartiles and upper quartiles. And let's do an example. So here we have a data set of the number of games that were won by the Detroit Lions in their last 10 seasons. And we first need to organize our data set from least to greatest. Go ahead and do that now. And if a number repeats, write it again. So all we've done so far is organize our data points from least to greatest. And what I find helpful is checking off the box or the numbers when I write them to make sure I'm not writing them twice and I'm counting all of them exactly how many times they show up. So here's our new data set. We've organized it from least to greatest. Our second step that we have to do is determine the median. And if there's an even number, we need to take the mean of the two values. And if there's an odd number, then we just circle that median. So first off, here we have our lower extreme, which we could also call our minimum. And here we have our upper extreme, which could be our maximum. So to find that median, we're going to check off the box, check off the low and the high and the low and the high and the low and the high and the low and the high. And here we get two numbers that could be our median. So we need to find the mean of them. In this situation, they're exactly the same number. So I know that my median is going to be 7. And it's going to be right in between these two values is going to be 7. But to find that mean, let's say the numbers were different. To do that, we would take them and add them and then divide them by 2. So we would get 7 plus 7, which is 14, divided by 2, which is just 7. So we know our median is 7. And it's right in between these two 7s. So neither of these specific 7s are the median, but there's a value in between. That's our median. That's going to be 7. So now we've done step 2. So our next step is going to be to calculate that 5-number summary. So our lower extreme is our lowest number, which we know is just 0. Our upper extreme for E is that highest number, which we know is 11. We have calculated our median, which we know is that 7 wedged in between those 7s that we have. And now to find our lower quartile, what we have to do is take the median of the lower half of our data. So here's the lower half of our data, and we're going to include this 7 because it's not the median. So now we need to find our median here. So we're going to check off our lower and our higher, our lower and our higher. And we have one number that's in the middle, which is that 4. So our lower quartile is 4. And we're going to do the same exact idea for our upper quartile. So what's going to be our upper quartile? Well, looking at our upper half of our data, including that 7 because it's not the median, and going to our upper extreme, we can check off the lower and the higher and the lower and the higher and get that 9 is exactly in the middle of the upper half of our data. So our upper quartile is 9. So now we're going to take our 5-number summary that we have right here and actually plot our box and whisker. So we need to draw our number line that we have, and we have a number line down here. And we need to label our 5 data summary, which is from 4 to 7, 0 to 4 to 7 to 9 to 11, where 0 is our min, 11 is our max, 7 is our median, 4 is our lower quartile, 9 is our upper quartile. So on my number line that I have right here, I'm going to label my values. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now we're going to draw our 5-point summary in order to make our box and whisker. So the absolute lowest point of my data point is going to be at 0. So I'm going to put a dot there. My absolute highest point is going to be at my maximum, which is at 11. My median is at 7. My lower quartile is at 4. And my upper quartile is at 9. So to make my box and my whisker, I need to draw a box from my lower quartile to my upper. So from 4 to 9 is going to be my box. having my median right in the middle right here. And then I'm going to attach my whiskers by going from my upper quartile to my max and my lower quartile to 0. So here we have our complete box and whisker from minimum to lower quartile to median to upper quartile to maximum. So I could ask you a question of how much of our data in terms of percentage is from the values of 4 to 11. What percent of my data is from 4 to 11? Well, knowing that each of these sections has 25% of my data, that would be 25% plus 25% plus 25%, which would be 75% of my data. So here's another example. We have resting heart rates, which is measured in beats per minute, or BPM, of the group. Find the 5-number summary and draw your box and whisker plot, and then answer the questions that follow. So our first step is to organize these from least to greatest. So go ahead and do that now. Now that we've written our data set from least to greatest, we need to go ahead and identify our 5-number summary. So finding our min, max, median, and lower and upper quartile ranges. So the easiest ones to figure out are the min and the max. So our minimum that we have right here is 50, and our max is 92. Let's go ahead and fill that in. Now to find our median, we count from the min and the max all the way to find that middle number. So we're going to tick the low and the high, 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 the low and the high. And now we're stuck between two numbers. So we need to find the median between them. And we can do that by doing 64 plus 68 divided by 2. And getting that our median is smack dab in between these values, and it's going to land us at 66. So our median is 66. Now we're going to do a similar thing for that lower and upper quartile range. We're taking the median of the lower half of our data and the median of the upper half. So if I have my lower half right here, I want you to go ahead and find that median. So let's check them off. Low, high, low, high. And here we have another set of 2 that we have to wedge ourselves in between to get our lower quartile. So we need to do 58 plus 60 divided by 2. And you can also think about it like what number is directly in between 58 and 60. And we know that it's going to be 59. Or you can use the mean that we have right here to give us that same value. So our lower quartile is 59. Go ahead and figure out what our upper quartile is. Using what we know about how to find our median, we go from low to high, slowly checking them off until we're wedged in between these two. And to find that median, we do 72 plus 76 divided by 2, and we get that our upper quartile is at 74. Now we're going to use this 5-point summary in order to make our box and whisker plot. So we're going to make our number line, and it needs to go all the way from 50 to 92. So I'm going to make my number line go by 5. So I'm going to go 50, 55, 60, seemed like a reasonable way to space it out. And now we need to plot our 5-number summary. So I have my minimum at 50. My maximum's at 92, so somewhere between 90 and 95. Our lower quartile is at 59. Our upper quartile is at 74. And then our median is at 66. So here we have our 5-point summary. And now we're going to draw our boxes and our whiskers. So I have a whisker from my lower quartile to my minimum, a box around my quartiles, a line for my median, and then a whisker right here. So here we have our complete box and whisker plot. And then we're going to use these to answer some questions. So the question that we're going to be asked first is, what is the range? So let's go ahead and I'm going to move my box and whisker plot over here so we can see it. And just like some magic, we have our box and whisker plot and our 5-point summary that showed up. So to find our range, we need to take our absolute maximum and subtract our absolute minimum. So in this case, it's going to be our max, which was 92, minus our min, which was 50, to give us that our range is 42. Now the inner quartile range is taking that upper quartile and subtracting our lower quartile to give us our inner quartile range. So that's going to be our 74 minus our 59 to give us our inner quartile range, which is 15. What percent have a resting heart rate of less than 66 BPM? So we know that our median is exactly at 66. So what percent of our data is below that? Well, our median cuts our data exactly in half, so anything that's below or above that is going to be exactly 50% of my data. What percent of the data have a resting heart rate no more than 74? So no more than 74, my absolute limit is at 74. So what percent of our data is below that? Well, we have this 25%, this 25%, and this 25%. So 75% of my data has a resting heart rate of no more than 74 BPM. What percent have a resting heart rate between 50 and 59? Well, that's talking about from my minimum to my lower quartile, which we know is exactly 25% of my data. And then what percent have a resting heart rate between 66 and 92? So that's going from my median to my upper extreme, and that's going to consist of 50% of my data. So using our box and whisker plot that we made, we can answer a whole bunch of questions about percentages and then finding those ranges as well to give us an idea of how spread out our data is and where it's lying. So now we can do what's known as comparing them. So you can be given two box and whisker plots on the same number line and have to make some comparisons or observations about them. So for question A, what was the height of the tallest male student? So notice how the top box and whisker plot that we have is dealing with boys, and the bottom one that we have is dealing with girls. So if it's asking for the height of the tallest male, we're going to be using the maximum on the upper box and whisker plot, and that would be at 74 inches. That's how tall the tallest guy was. And then it's asking, what is the height of the shortest female? Well, to answer that question, we have to look at our minimum on our girl box and whisker plot, which is all the way down at 61. The lower quartile for the boys is what data point for the girls? So here we have our lower quartile for the boys. What data point does that line up with the box and whisker plot for the girls? Well, we can see that it's lining up with the upper quartile of the girls. The upper extreme for the girls is what data point for the boys? Well, here's our maximum for the girls, and that's lining up directly with the median of the boys. Do the boys or girls have a greater inner quartile range, and how do you know? Well, visually looking at it, we have our quartile range for the girls, which is right here, which is going all the way from 63 to 68. So they have an inner quartile range of 5. And then for the boys, for their length of the box, it's going from 68 to 72, which we have as 4. So the girls have a bigger inner quartile range. And then do the boys or girls have a greater range in general? So I'm going to go ahead and erase all the stuff that we have here so it's not confusing. So in order to find that range, we have to do the min and the max of all of the data. So for the boys, it has a max of 74. We need to subtract its minimum, which is at 66. And then for the girls, it's from 69 down to 61. So 69 minus 61, we know is 8. So in this case, they actually both have the same range. They both have a range of 8. So neither has the greater range. They're the same. And then the last question says, what percent of the girls are 63 inches or taller? So here we have 63 or taller. So covering this whole span that we have. Well, it includes 3 sections. One here, and one here. So 75% of our girls are taller than 65 inches. Here we have another example of comparing. So Mr. Athens and Mrs. Gilman gave the same test, and here's the scores. What's the difference in the median scores? So Mr. Athens, his median was at 80, and Mrs. Gilman's was at 75. So the difference in the median is that 80 minus 75, which is a difference of 5 points. Which class had a greater range of scores? Now you can actually just visually see this by seeing how spread out the box and whisker plots are in comparison to each other. So look how much more spread out Mr. Athens' class is from his min to his max in comparison to Mrs. Gilman's min to her max. So the greater range we know is Mr. Athens by far, because his graph from min to max is way more spread out. And then which class do you feel better about? That's kind of an opinion. I mean, Miss Gilman's class had a min of 60 rather than Mr. Athens that had a min of 45. But his median was higher. So it kind of depends on how you view it. Because I could say that 50% of his data was 80 and higher, and 50% of her data was 75 or higher. But he got 100% and she only got a 95. So it kind of just depends on how you spin it. So then in this example that we have the Lucky Strikes and the Alley Cats that are 2 teams at a bowling league. The box and whisker plot shows the scores for their last game. There are 12 bowlers on each team and each bowler scored a different number of points. So what's the difference in the upper quartile between the 2 teams? So here we have the upper quartile of the Alley Cats. Here we have the upper quartile of the Lucky Strikes. So we can see that it goes from 220 to 210, which is a difference of 10 points. And then the next question says, what percent of the bowlers on the Lucky Strikes scored less than 210? So the Lucky Strikes had an upper quartile of 210. So what percent scored below that? Well, we can see that that includes 3 different sections of 25%. So the percent of the total team that scored less than 210 points for the Lucky Strikes would be 75% of their team.